Hi, this is the DefCamp CTF Qualifiers 2017 qualifiers. So I've been through and gone through the junior challenges in the CTF. I haven't completed any of the extra web, reverse engineering or miscellaneous challenges, but I've done all the junior challenges, so I'm going to run through the solutions to all of them in order. If you want to skip to a challenge, if there's any of these challenges you're working on and didn't solve, want to see how I did it, then you can go down the description and just skip to the challenge that you want to take a look at. Okay, this challenge is called Super Secure, and the description says, Oscar is more of an offline type of guy. Can you hack his platform? So it has a website address for us to go to. Okay, and if we go to the web address, we have a login page. Go and have a look at the source. This is how we will trick our attackers to input only emails and how we'll avoid brute force. So you can see we have a client-side validation here. The username is set to, this is not admin email. Password is set to a very safe, secure password. Also, this is brute force tested. So it's going to check the username that we enter matches this username, and the password we enter matches this password. So if we take a copy of that and a copy of this, but we have this client-side validation saying please enter an email address. So we open up our console here, developer tools, and let's inspect that element. That's this one here. The type is currently set to email, so if we change that to text and then log in, there we go. Okay, so with all due respect, do you think I'm smarter than you? Don't you think I will keep my stuff online? Blah blah blah. Okay, so it's saying you need to go offline here, so let's have a look again at the source. This time around we have a script, offline options. This is where it's checking to see whether you're offline or online. Now I have already had a look through the challenge. We can see here there's a comment saying should we show a snake game? If so, you should bring it in addition to offline.min.js, which you can see is imported here. So if we open that up, we'll get that script. Let's go then to JavaScript beautifier, paste that in, beautifier, and we can go through the code here. I spent a good bit of time going through this code, trying to mess around with the JavaScript on the client side around here, you know, actually taking the system offline, going through and modifying some of the elements in the HTML. So for example, if you modify some of these to some of the values that you see in here, you'll get some different UI, but it will still never show the actual flag. How I ended up actually finding the flag was when I noticed the style sheet. So you have two CSS files, slide and slide 2. So I open up slide, scroll through it, don't see anything interesting. Go back and have a look at slide 2. And what do we have here? The flag, the flag, the flag. So it looks like basically if it was showing that it was disconnected, if you're offline, then it would change the style sheet, and in doing so would give you this flag. Okay, this is the Hex Warm Up challenge. The description says, a friend of mine is learning about encryption and now is challenging me to break it. Can you give it a go? So you download a zip file which has this junior folder in it with a lock.iso file and ransomware.py. So the first thing I'll do is open up the ransomware.py file. And we have some code here. So the backup.zip file was opened. It was read into the buffer, all the content was read into the buffer and then printed out. It was then encoded into hex, and these values were all added onto the buffer. And then before the buffer, this BUL, it adds these hex values to that, and then it's going to create the buffer as being this, followed by our backup.zip text, converted into hex obviously, followed by this. And then it's going to be decoded, and it's going to be written to the lock.iso file. So we need to think about this really in reverse. So if we were to read this content from the ISO file, turn it back into, encode it into hex, and then remove the last however many values this is. These are 32, so 1, 2, 3, 4, 5, 6, 7, 224, I think. Yeah, okay, and then so we need to remove that from the beginning of the string, and then we need to remove this from the end of the string, and then we need to decode it so it's back into text, and then we'll print a buffer. So essentially we're just going to be reversing this. I'm going to copy this onto my other monitor to go through. So the first thing was the creation of the buffer, and this time we'll be opening the ISO, so also in read mode rather than write. We want to create the BUL. Oh no, sorry, we don't need BUL. Okay, so we want to set buffer plus equals g.read buff maybe I'll just bring this back just to show what we've done. So again, we are opening the lock.iso in read mode. We're creating our buffer where we're reading from this, which is kind of what happened up here, and then we are encoding as hex because we decoded here. Now we need to remove the BUL, which is at the start, and remove the BUF, which is at the end. So so if we take this substring buff equals buff, and then I think 224 minus 1000. So take the last 1000 characters off and the first 224 characters off. Decode it back to ASCII and print. So try and run that. So we don't really get any, we certainly don't have a flag here. What we do see is index.txt a couple of times mentioned, and we have pk a couple of times, which is the extension for a zip file. So let's try to run foremost. And unzip that. Okay, so this is your flag. You could have also done it by running this script, or you could simply change the extension. Okay, so we went around quite a long way of getting the flag. We should have maybe done some basic checks first, checking the file type, having a look at the ISO, but cool. This challenge is called Too Easy, and the description says, "Ah man, I hate it when I forget my password, do you know it?" So you can download this executable, looks good.exe. If we have a look at that, it's a 64-bit Linux executable. Have a look at the strings. Sometimes okay. Enter password, now decrypt hex, strong password, and you can see here strong password as a pro. And there's some hex values anyway. Just so it's easier to get the I'm assuming it's going to print out this value is in an easier format for me to decrypt, so I'm going to try and run it. Just set this to executable, enter in that password, and there we go. Yeah, it's given us a long hex string. Okay, so go online and go to any hex converter, ASCII to hex. The theme on this, we can see it kind of messes up with the colours, but oh well. Convert. What text have we got? We've got the flag. That's the flag there. This challenge is called Know That Kind of Network. I think it means not that kind of network. And the description is, I like to write and move all around the world, but do you know my story? So we download a PCAP for this called kingofstone.pcap. So first thing is to open up Wireshark. Quite a lot of packets in here. If we have a look at statistics, average packet size, okay, see a little bit of text there, data, traveller, serial number, Kingston. Okay. What I'm going to do is I'm going to just go back to, I'm going to go and filter this by size. Okay, start from the top. Okay, we have a lot of colons in this one. And a lot of asterisks in this packet. Okay, I'm basically just going from the largest packet onwards just to see which, if any of them have any text in them that recognizable, or anything that can be, looks like you might be able to extract it. Okay, so we see a mention here of flag.txt, trash, so it looks like it's been deleted. Oh, there we go, there's our flag. Cool. This challenge is called Is Nano Good? And the description says, this is our new admin platform interface, can you test it? So we have this website here with a login page. If we try to log in, it doesn't take us anywhere interesting. I'll just show you quickly. So we just get to this page, there's nothing, no source, nothing to look at. If we look at the source on the login page, we have a comment here. Probably at some point you'll figure it out that you should always press Control and U, which views source, to see if this page is just plain HTML page and you don't have to break this. Have you tried index.php? Maybe I was lazy enough to edit it with Nano. So that's the only really interesting thing on the HTML is the comment here. My instinct here was to try and access the Nano RC files on the file system. To do this, we would be looking at directory traversal. So just to test this, I was going to etc password, and this is what happens. So yeah. That doesn't happen on other web challenges, so they've obviously specifically added that in for this, which makes me think I'm going along the right lines. I started looking at a lot of different obfuscated versions, so there are a few in order to bypass directory traversal filters. There are some obfuscation techniques you can use. For example, this is the same as what we just did with the etc password, just we've encoded the dots and the slashes. There are a few different encoding techniques that I tried here, and all of them take me to a different page, but unfortunately still not the page that we're looking for. In terms of index.php, it's saying, have you checked index.php? I don't see any sign that we're going to get anywhere. I've tried all the usual stuff. Have a look at robots, and but yeah, unfortunately I haven't been able to solve that one. This is a challenge called Hit and Split, and the description says, are you a forensic? And you have a PCAP that you can download called Split and Hit. So first things first, to open up Wireshark with the PCAP, and it's a good idea just to have a quick look whenever you open Wireshark, to have a look at some general information about the file. If we go, for example, and have a look at the protocol hierarchy, there might be something in here which is particularly interesting. You might see something that just says, text or something like that, where you might want to go then and filter it, so that's all you'll be shown. Okay, doesn't seem to be of any use. Another good thing to do is to go and have a look to see if there are any exportable objects, particularly HTTP in general. Not in this case. So let's have a scroll and have a look through. We have this our telnet data here, and you can see there, try harder. Let's follow this. So the values being entered in, we've got this back and forth communication between the .113 and .120 address, and numbers being sent, and it's responding, try harder, try harder, try harder. Okay. But it only went up to 8, so here's some more. Welcome to the obfuscation server. Type something, we will obfuscate it. Okay, still nothing too useful. Let's exit out of that. What I'm going to do is go down to here. We have our telnet. If we apply as column, no, sorry. We will apply the data as a column. Now we can kind of more easily see, just scrolling through what's happening. These numbers are being sent, it's still saying try harder, try harder, try harder, okay. Try harder. Flag in here. Okay. So there's quite a lot of attempts here. Don't seem to be getting anywhere. Until we see this. Okay, so let's follow the TCP stream. We will take a copy of this. Take a copy of that, and then what's happening here? So from now on, the flag will continue. So again, try harder. Okay, so if we keep scrolling down. Oh, sorry, I'm still filtering. Okay, so we have initial, and then we have more here. Okay, so let's follow this, and yeah, we can see we've got some more data. So take that, take that, take that, and take that. And there we go, we have our flag. This challenge is called 1,000 words, and the description says, I bet your eye can spot the original photo. So we have a zip archive here with images inside it. So we'll create a new directory. Okay, and then we'll unzip the images. We'll then remove images.zip. You can see we've got 1,154 images. If we go and have a quick look at them, they all appear to be the same image. If we go to do a comparison with ImageMagick, so we're comparing all.png and then creating one single and that's what we have. So definitely no flag sitting there. What do we have here? Okay, so it looks like there's a comment that's been added into this. Let's have a look at the second. Same. Third. Same. Fourth. Different. Okay. Okay. We'll try and grab strings that are greater than 10 characters in all of the PNG files. So we're seeing quite a bit of that. Okay, what do we see here though? D-CTF, 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 D-CTF. Let's try and grab all strings that are greater than 10 from all images, and then let's grep out D-CTF, because we know that that's what the flag is going to begin with. It's going to begin with D-CTF and then curly brace. There we go. Okay, so we have the flag. Okay, this challenge is called Loyal Book, and the description says, every book is unique in its own way. Go ahead and read the story of a brave man. So you download these books, as you can see you have books.zip, so we'll unzip the books. We have 10 books. We can have a look at one of them. Okay, it's a long book. Let's try and grab strings greater than 10 from the first book. Well, it's not going to do us too much good. Let's get strings greater than 10 and grep out D-CTF. Nope, nothing. Let's try and do that in all of the text files. Nothing. Okay. Let's try and diff all. Let's try and diff 001.txt with 0002.txt. Okay, and with 3. Okay, cool. So you can see a pattern here. Basically, this is when we're doing a diff here, we're seeing that the difference between the first file and the second file, the only difference is the same book. The only difference is that this one has a DC in. If we compare the first one to the third one, the only difference is this one has a TF in. So that's obviously our D-CTF. So I'm going to create a new text file and D-CTF, we know there's going to be curly braces, so let's have a look at 4. What's the difference here? Oh yes, curly brace, okay. What about 5? The difference here is 7 BA61. And then now you have to be careful here because we have the word was, and then we have this string, but it's obviously placed itself in the center of was. You can kind of see a pattern here that looks like it's going to be 5 characters per time, so just bear that in mind when going through. Okay, so this is in the middle of the AND statement, but there's still an extra A. Okay, nearly done, there's only a couple more. Text files. And the last one is this one, so E3DE. Sorry, I missed one there. So it was this one, this one. We had this one first, so okay, and then this one. this one, this one, and finally this one. Oh, not finally, sorry. We have one more. So this is our flag. A bit longer than the usual ones, but there we go. Okay, this is a challenge called Inception, and the description says, do you like our logo? So you download this image, you may not see me.png, and open up the image here. Doesn't look like anything out of the ordinary. So the first thing we'll do is just double check the file type. See, it's PNG, that's fine. Have a look to see if there are any strings worth which might be interesting. We will try and run foremost, as the challenge type is called Inception. And we can see we have a range of PNGs. Oh, there we go. And there's our flag. This challenge is called How is your memory? And the description says, well, here is a small application to test your memory. So we were given this memory.pcap file, but obviously the description says it's a small application, so we check the file type and we see that, yep, it's a 32-bit executable. So let's change this to, let's move it from memory.pcap to memory.exe. Let's change it, make sure it's executable. And let's have a quick look at the strings. So we can kind of get an idea of what the functionality of the program is from here. See some memory addresses, dead beef, looks like it's going to be buffer overflow related. A couple of other strings in here, but it's worth checking strings to see if there's any obvious sign of the flag or a password or something like that. So let's try and run memory.exe, and then we get this message. So we had to press enter there, can run it again, press A. You've sent this message A, instead of 0x dead beef it received this address. So what we want to do is keep trying to send this larger inputs until we can see if we can overwrite this, and there we go. So instead of dead beef, it's now received 414141, which obviously is all A's. What we need to do is we need to overwrite it with enough A's until we get to the beginning of this address, and then overwrite it with dead beef. So you could use some tools to do some fuzzing or write a script or something here, but seeing as the size of the buffer isn't very large, there's not really much point. So the way I did this was just using Python-C print A. I've already done it and worked out that the right amount here is 40. So let's pipe that into memory.exe. Okay, so you've sent this message. Oops. There we go. You sent this message. So if we change this to 42, see it overwrites 2. Yep. 2 bytes there. So, and that's 1, and then again we can go up to 3. So basically, yeah, we want it to be 40, and then we need it to have dead beef. So to add the dead beef, what we want to do there is we need to put this in hex, so it'll be \x for each byte, and we need to do it in reverse order because it's little endian. So we'll start with DE, then we're going to move back here and do AD, move back, BE, move back, EF. So we've got it in reverse there. Try to run it. and there we go. But it's still saying instead of dead beef it received dead beef. Meh, you did it. I'm not sure you know what you did there. Again, is your memory good enough? So then it comes up again that you've sent this message instead of it receiving 4141, so capital A, capital A, capital B, capital B. It received 0 F F F F F F. So right, I tried kind of going through with ltrace, trying to work out what was happening with the program. I was trying to see if I could overwrite this buffer as well after this, but yeah, wasn't really having much luck. Ended up turning to GDB, which I'm not particularly good with. But in GDB, did I run? Yep. Okay, so we can disassemble. Oops. We can disassemble the main function here and have a look through the code. So we can see some mentions of, for example, dead beef here. It's doing a comparison. It's saying jump if not equal to whatever address. And then we have the similar sort of thing down here where we have the 41414242, and it will jump if equal, again jump if not equal. Yeah, so I was kind of hoping whenever trying to solve this that we would overwrite with dead beef just as I had done, but then set a breakpoint and then jump down to closer to where this comparison is with 41414242, and then just modify the registry or do another overflow. It didn't. I couldn't get that working. I'm not too sure how I can kind of use the Python kind of functionality with GDB in that way and still set breakpoints. So the way I ended up approaching this was to not even try to do the overflow that we did there. What we want to do is, before it even asks us for input, which is around here, we want to set a breakpoint there. So if I copy this address and I set B to this address, set that breakpoint. What do we want to do when we hit that breakpoint? Well, we could be going into, as I say, my original thing was to try and set a breakpoint around here before this comparison and then modify the register so it equals dead beef, and then later we'll do the same thing down here. So you might be able to get that approach to work. I couldn't, so rather than doing that, I figured let's avoid all these comparisons. So let's avoid that comparison up there, and this comparison here, let's avoid that as well. So the last comparison that you see here is this one, and afterwards it'll jump if not equal, and that was the problem that we were having. That even if we overflow the first one, we're not meeting this condition. But we could just skip all this. So if we take this, the value here, so just forget this jump not equal because that's not what we want to do. We take this value, let's run the application. We've now got a breakpoint, and if we go here and have a look at info registers, we'll see that we could, as I say, we could have gone and started trying to, I think it's the EBP register that the dead beef comparison is done at. Dead beef, yeah. We could go and start trying to modify that, or we could just modify the instruction pointer. So, oops, we've got the address copied, so let's go to an ASCII to hex converter. Take away that x0 at the start, convert it, and we want to take the decimal value. And if we go back here, we can set
the instruction pointer to equal this value. So at the moment the instruction pointer is set at the breakpoint that we've just stopped at, which is good. Now we want to change it and we want to have a look info registers, and now we'll see that it's actually changed to the value here that we want to jump to, which was around here. So we still want to execute all this, so let's continue the execution. And okay, wow, I'm impressed. Now for the last time, here's the flag. Now we know the format of all the flags has been SHA-256, and in this case it's not SHA-256, so it looks like we need to generate one. So we can take a copy of this and we can go and echo without the new line this value into SHA-256 sum. We'll print this value, and that's our flag.